Okay, on to the next problem. Again, we're just going to find the zeros. X equals -3. And here, you might want to set up a little equation. 2x minus 3 equals 0. So add 3, divide by 2. So our critical points were at 0, where the sign changes, is at -3, and positive 3/2 or positive 1.5. Okay, plugging in a -4, I get a negative over a negative, overall positive. 0, I'll get a positive divided by a negative, gives me an overall negative. And 2 is a positive divided by positive. Okay, so this is asking where our rational function is less than 0, so it's asking where is it negative. And that's going to happen at that interval. And they want interval notation, so I'm just going to skip a step and leave that. And open points between that and 1.5. Okay. Again, kind of the same idea, but we're going to have to do some factoring in the numerator. X plus 3, x minus 3, which gives us zeros of -3 and +3. And then we also get a 0 at 1. All right. Plugging in a -4, and I prefer to plug in looking at the factors because it's just easier to do. So I'll get a negative over another negative. So that is overall negative with a 0. Now that I can see with just the x squared minus 9. But 0, I get a positive, a negative divided by a negative. So that will definitely go to positive. Two positive, negative over positive. So that goes to negative divided by positive. Definitely a negative. 4 positive over a positive. So our question is asking, where is this less than 0? Where is it negative? That is going to be here and here. And in inequality notation, that's going to be x is less than -3, or x is between 3 and 1. Okay, these get tougher. We have to add these. All right, and to do that, to add two rational functions, we need to figure out the LCD. And that helps to factor. Okay, so any duplicates go into our LCD. So x plus 1 shows up in both of them. and then we throw in everything else that's left over. So that's our LCD, and then the next step, I'm going to take this fraction and convert both parts to the common denominator. Now, I have to multiply this to get my common denominator. I need to throw in an x minus 1, which means I've got some binomial multiplication when I get to that step, plus the only thing missing there is the 2. So everything's going to go over that common denominator. And now I'm going to simplify the numerator. I'm going to put it all together. So when I multiply that quadratic, I get x squared minus 2x plus 1. And then 1 times 2 gives me another 2 to add to that. And boy, am I running out of room. X squared minus 2x plus 3 over that was an error. Let's try that again. Just getting ready to write it again. Okay, the numerator can be reduced, or sorry, factored. X minus 3 times x plus 1. Now, this is important. Because we can factor one of these out, they aren't included in our critical points. Let me get some more room. So our critical points are at, in the numerator, I have a positive 3. In the denominator, I have a 1. Okay, now plugging into my reduced function, and I'm going to have to kind of work around. Now, the 2 doesn't matter. I'm just looking at the x minus 3 in the numerator, the x minus 1 in the denominator. If I plug in a 0, I'll get a negative over a negative, overall positive. If I plug in a 2, I get a negative over a positive, overall negative. And I plug in a 4, I get a positive and a positive, overall positive. And the original question asked, where was this rational addition greater than 0? So where is it positive? That is going to be there and there. And what kind of notation do we need here? Interval notation, yay, because there's my interval notation. And now I'm going to just graph it. Do we have equals part? Yes, we do. Okay. See you on the next video.